Let's solve some logarithmic equations. So in this problem, we're looking at it, and we notice that there are two log functions, and then on the other side of the equation, there is a number by itself without any log function. So when we have this situation, we should think about our techniques, and the technique that should come to mind is change from log form to exponential form, since there's a number on the right hand side of the equation. So we're going to collapse the two log functions together using our log properties, which we get the log of 2x divided by x minus 3 is equal to 1. Now we can change from log form to exponential form. Notice this is a common log, so the base is 10. So we have 10 to the 1 is equal to 2x over x minus 3. And now we have to solve this, so let's multiply both sides by the common denominator to clear out the fractions, giving us 10 times x minus 3 is equal to 2x. Distribute the 10. Let's bring the 2x to the left-hand side and the negative 30 to the right-hand side. So we have 8x is equal to 30. Dividing both sides, we have 30 divided by 8. Do a quick check to make sure this is okay. 2 times 30 divided by 8 is a positive number. 30 divided by 8 is bigger than 3, so that is a positive number as well. Nothing's to be worried about here. This looks fine. For the next one, we look at the form of the problem. We see a log equals a log, and a log. So we should be thinking about our different technique, that is, the log of m equals the log of n can be written as m equals n. In order to get it in that form, we're going to have to collapse these log functions together, but in order to do that, we need to take care of the powers first. So we have log base 3 of x minus log base 3 of 5 squared is equal to log base 3 of x plus 1 minus log base 3 of 10 squared. Now we can collapse these two together on the left-hand side. Log base 3 of x over 25 is equal to collapse these two together on the right-hand side. Now what we have is log of m is equal to the log of n. Therefore, x over 25 is equal to x plus 1 over 100. Let's multiply both sides by the common denominator, which is 100. That will clear the fractions. If I multiply the left-hand side by 100, then 100 divided by 25 is 4. So we have 4x. If I multiply the right-hand side by 100, we just get x plus 1. Subtracting x from both sides gives me 3x is equal to 1, which means x is equal to 1/3. Is this okay for x? Substitute x equals 1/3 back into the original problem, and it's okay there, and it's okay there. Everything looks good. This last problem is a little tricky. Notice that we have numbers to powers, and then constants. So this number to power is different than that number to power. But there's a hint, there's a clue here. This number is double that number. So the way we're going to do it is we're going to think about 3 to the x squared plus 3 to the x minus 2 is equal to 0. And what we want to see is if we call a different letter 3 to the x, then what we get from this is u squared plus u minus 2 equals 0, and it looks like we have something that can factor. How does this factor? U plus 2, u minus 1 equals 0. So that means u is equal to -2, or u is equal to +1. But u is not what we're looking for, it's x. So 3 to the x is -2, and 3 to the x is equal to +1. Now that we're at this step, we can change from exponential form to logarithmic form. So this is log base 3 of -2 equals x, and log base 3 of 1 equals x. For the first one, log base 3 of -2 equals x, that is undefined because you can't have a negative number as the argument of a log function. For the other one, log base 3 of 1 is 0. That was one of our properties. Log base a of 1 is 0. That is 3 to the 0 power equals 1. So the key for this problem is to see if you can write it in a form where it looks like a quadratic type of problem in order to use factoring or the quadratic formula.